Well, thanks for coming on the show. We probably won't talk much football today, but we'll see. You have such a fascinating career, from submarines to hyperscalers to your current role over at Oracle. Like, what stands out? What are some of the milestones of that journey? How curious experience that must have been.
It's been, you think back, every 5 years, I think, you don't realize how quickly time flies, especially once you have kids, and, each project that we work on, they take so long to go from inception to completion that by the time you're finished, you're like 3 or 4 years has gone by.
Yeah.
When it comes to my career, I'm a little bit odd in that, when I was in 8th grade, I decided I wanted to go to the Naval Academy. I wanted to be a submarine officer, with a systems engineering degree. Uh-huh. It was actually the only school I ever applied for. I actually got in early before the beginning of my senior year, which didn't work out well for senioritis. Motivation was a little lacking.
Right.
But, I've always enjoyed doing hard things. And I think, when looking at kind of being a submarine officer, doing nuclear power, you don't really know as an 18-year-old, kind of what you're getting yourself into. I mean, heck, at this point, I'm considered an adult by law, but, often I don't feel that way. Yeah. And I think when you look back, when it comes to the decisions and kind of where my career has gone, I've found that, working hard and like learning the job that you're in has always set me up for the next job. And the more I put into figuring out the things that I didn't know, that's kind of where it kind of led me, as I progressed. Even when I got out of the Navy, Google had gone to only a couple of hiring conferences, when I transitioned, and they happened to be there for one. And I was like, I don't really know where my skills would fit in. And they're like, well, we build data centers. It's essentially a critical facility. And then once you start learning about it and, seeing, it's like, oh, this translates very, very well to kind of what I had done. And then it was just about opportunities. When they interviewed me, they said, would you be willing to move overseas? And I said, yes. And so when I actually signed my contract, I actually didn't have a location. I was in Austin at the time, and they're like, it's either going to be Belgium or Finland for 2 years. My wife said, I can do anything for 2 years. She former military, so we'd moved 7 times since we'd been married at that point in 5 years. And so went over, and then things just kind of progressed. And, I've always enjoyed working on the hard things, when stuff breaks or when things don't go well. Digging in, to the nth degree, that's what I find interesting. I'm not the kind of person that enjoys repetitive things. If it's repetitive, I want to create organization or a method to automate it. I like when people say we don't know what's going on, my ears perk up, right? And because I think in terms of systems. And so as I look at my progression in my career, that's kind of how it's gone, is it's always been getting more and more into the bigger systems, right? You start as a junior engineer on a submarine, you're learning all of the simple systems, and then you combine them into the large submarine. And then you will learn about how does that submarine fit into the larger strategic objective. Same thing in a data center, right? You learn particular systems, and then you understand how they impact the business. And I think the biggest transition that I have seen for my career is once you realize that engineering serves a purpose for the business, it allows you to see how engineering decisions are made at an executive level. And as an engineer, you're like, why didn't they choose the right technical, right in air quotes. Right. But as an engineer, once you progress beyond that part where you understand speed to market, where you understand, CapEx cost versus OpEx, you understand how to avoid both of those things and where schedule comes in. That's where you start changing how you think about designs, and that's where you become very, very effective. And then as you start thinking strategically, 1, 3, 5, 7 years out, then it gets very, very interesting to design towards that goal.
When you started playing hockey when you were a kid, did you still have, like, was this natural to your DNA, or did this get formed when you were in the Navy?
My dad played hockey growing up, and so I started skating when I was 2. Played hockey since I was like 4. I think the curiosity I was the kid that, would take a wire and, short out the outlet, what does this do, sort of thing. I think that curiosity kind of always exists, right? You take apart a watch, or you take apart, the broken radio, or it wasn't broken, but now it is, kind of thing. I think that curiosity just comes from wanting to understand things. And so for me, and kind of the way I teach my kids, I don't actually answer the questions they ask a lot of the times. I'll say, well, what do you think? Or, did you look this up, right? It's more about giving somebody the answer. It's, the old parable, right? Teach a man to fish kind of thing. And I found that the most successful leaders that I've worked under, or, the best mentors that I've had, were the ones that didn't give me the answer. They gave me the framework to find it myself. And then not knowing the answer is very different from understanding a concept. I found in school that I would tutor people, in nuclear power school, where they're like, I really don't understand this. Well, we'd sit down and I'd kind of tutor them on the concept, and then they'd go get a 3.8 or a 3.9 on the exam, and I'd get like a 3.4. But it was because I didn't learn how to take the test to play the game. I understood the concept, and so I didn't show all of the work because I understood it, and so you'd lose points. And so that was an early lesson to me that there's two parts of it. There's knowledge, and then there's how do you apply the knowledge in the way that fits within the rules of the game. And so we've seen our industry change in the last couple of years, where the rules that we had been abiding by no longer apply. And that's where the challenge is, and where the fun comes in, is when you have to understand both sides of it and be able to predict which one, or be ready when they both change.
Yeah. When you're talking about, you've got a problem that shows up, a business opportunity. So you've got a technical problem that you're trying to turn into a business solution, or vice versa. And when you're talking to executives, how do you have that conversation? Because they might say, look, first mover advantage gives us all of these things. Well, for sure, it could. But here's the consequence 3 years down the road. And so is the first mover advantage enough to overcome? Because this isn't a bridging thing we do if we do it like this. This is a throw it away. And so if we don't care because we're a public company or whatever it is, like that's somebody else's problem, or we'll build a second one or whatever. In other words, that tension between the total cost, whatever you mean by cost, whether that's monetary or time or market share or whatever, to balance as you're evaluating different ways to solve a problem. And the business people are saying, well, here's our business objectives. EBITDA has got to be this, or these are the things, the market share or whatever. I hear you, but here is the consequence of these various technologies or technical solutions to the business problem we're trying to solve. I guess how do you get sophisticated at, one, have that conversation, and two, persuade, whether you're the business people talking to the technical or the technical to the business, first to understand and then be understood. How do you have that conversation?
Remember that wisdom is always in hindsight, though, right? So you don't ever recognize in the moment that, wow, I'm very glad that you said that, right. That, it's always after the fact when you look back that you realize that when that decision was made, or the person that advocated foresight, they were correct in the long run. And so when you're dealing a lot with anecdote or gut-based instincts, where it's not data-driven, right? Where it's you do have the numbers, but you can't predict how it's going to affect you long-term. I think it's also a typical evolution of the way tech works, too. If you think about how a lot of the hyperscalers in our industry in general has kind of evolved, is it started kind of telco and moved into kind of the more traditional colo spaces. And then as that grew and as it evolved, you had essentially compute forward people now realizing that they were paying a lot for infrastructure. And so they've often, rightly and wrongly, depending on the company, believe that they could do it better. The typical tech, institutional arrogance. Right. when you get these people that believe that they can do it differently and better, they often go in with the expectation that people are doing it wrong. And so they don't approach it necessarily from the perspective of these people have lived it and, failures and blood and, sometimes lives have determined the path that a lot of these, utilities or large scale, construction companies operate under. And so until they recognize those truths, right, it's like physics, right? Physics hasn't really changed much in the last, I don't know how many thousands of years.
Well, not with that attitude. Come on, Luke.
Well, and see, that's the idea is that, successful folks that, have vision like that, they often disregard the truth. And it's a healthy disregard, right? Because if you accept it as always being a fact, there are things that shouldn't be considered facts. Now, should you challenge all things? I think there's a balance, right? But I think what you see is a typical evolution for a large scale, hyperscaler or even a large colo provider is as they, mature and the longer they have in that industry, they start having look backs that show them where they would have chosen to do things differently. But that recognition doesn't come early. And so what you have to do is you focus on what the executives are looking for, right? If there's a business need, if there's a reason that they need to do this, you need to understand that up front. You're not going to convince them that need is incorrect. But if there's additional things that can be done to enable the future, then you should do that, right? Don't design something without spare breakers because you never know what you might need in the future. The hyper optimization, focus. We've never had data centers require less power. So why don't we build in spare capacity in certain scenarios? There's a lot of design considerations, right? How do you build it faster, right? Most people who design data centers don't build them. And if you had to build them, you would design them differently. Same thing, most people that operate data centers didn't construct them and they didn't design them. But if they knew how ops was going to run them, you would design and construct them differently. So you talk about kind of the cycle, the life cycle of a data center design. They don't often include some of these folks in them. And so the more you have people with deep experience that can translate that back to the beginning stage, I'm not going to tell an executive that the business need that they have is incorrect. But all of the experience that the people that they've hired, we should be rolling those into that decision in a way that enables the future, right? So avoiding OpEx, right? If you look at your spares programs for some of these large hyperscalers, building it as fast as possible is the business need. But looking at, hey, how many parts do I need to stock, right? How many different brands of equipment do I have that, I have to have service contracts for? Do I make those in a particular region, right? You have to think about all of the things that lead to the outages that you read about in the newspapers. And if you understand that, then you can circle those back into something that they understand. Downtime, right? Hey, I understand that we're doing this today to get it out, but we need to design it in this particular way because if we have a failure, we will have downtime, and that could be significant if we don't have X, Y, or Z. You have to translate it into things that they understand versus trying to get them to view it from your point of view. Is one of the most interesting leadership courses that I ever took was when I was at the Naval Academy my junior year. We had, I think it was the Leadership Institute of America. They came and you did a Myers-Briggs test, which, have been, regardless of your opinion. What I found was fascinating is they didn't actually focus on your personality. They showed you what your personality type was, but they then taught you, and this was actually borderline manipulative in my opinion. They taught you that as a leader, your job is to flex to the personality of the person you're working with because you have control of your personality. You don't have control of theirs. So if they work better through if they're an intuitive person, right, you need to frame the things in a way that you understand how they view the world. And I found that was one of the most effective things because you walk into a room, your personality doesn't matter. It's the decision maker's personality that matters. Understanding how they want things framed, understanding how they view the world. It doesn't change my message. It just changes how I deliver the same message.
So one of the things we talk a lot about around here is operational maturity and the way that we we've borrowed that phrase, and the one that we like the most, I think, or at least let's just say me, I like the most, is the one when the Navy talks about operational maturity, which pains me as an ex-Army guy. But they talk about first expertise, like I memorize all the components, but then I've got the experience. So I've got it's like I've studied for the driver's test. Then I've gone out and I've driven. I've done the exercises following the not just the SOP but the MOP, and I'm running through my live fire exercises, whatever. And then I add to that discipline. Like, this is the list of stuff. This is the way we do it, and now we do it, and we follow the discipline, and then we, in a controlled environment with your leadership cadre or whatever, you iterate. If there's an opportunity to iterate, make it safer, whatever the goal is. And under that wrapper, we here add a couple other things to that, but that's basically what we mean by operational maturity. Was that your experience coming out of the Navy and the submarine to develop that maturity? And then what's been the opportunity to bring that into, big critical infrastructure once you get out of the submarine fleet?
I can't think of two industries that are more diametrically opposed than the submarine force and big tech.
Really?
Mainly because of how they view the world. Nuclear power in general is about stability, right? It's safety first. It is hot rock, make ship go is the submarine method. But even in commercial power, there's a perspective of longevity, right? It's 30 year, 60-year reactor, licensing. Whereas tech, it's a 3-month public cycle, that you have to show progress or, justify. And then you look at the way they do things, procedures. And, my submarine was designed in the 80s, built in the 90s, and I was on it it was probably designed in the 70s. Built in the 80s, and I was on it in 2010 or the 2000s, early 2000s. And so just the way that industry works, and it's like all industries as they mature. But what you find is, at least in the submarine communities, there's a couple of different types of folks. There are people that love that structure. They love being told exactly what to do, and it's easy and it's predictable. And then you've got the people that, and I fall into this category where you're like, well, you could do that better. You see the wisdom in it, right? The breakers have been the same breakers in like 3 generations of submarines. So people know how they work. Their spare parts are easy, right?
Supply chains is well developed.
Correct.
Right.
Yeah. So the logistics and all that. And what you see is, as a lot of these tech companies mature, they're learning the same lessons. And it's not that, nobody reinvents the wheel. They just discover that, their improved wheel is the same as the other wheel. And so what you find is you take the good from any industry and you apply it where it can be applied, right? MOPs, SOPs, right? But the biggest thing that the Navy teaches you is that you need to understand the why. Because what happens during a lot of dynamic situations is, yes, there's a procedure, but when you take those actions in the procedure, that validation of, hey, am I getting the right result, is the step that you'll often see people don't get. Is when I take an action, there should be a response to that action. And I should know what that action response means. And so it's the same thing in like engineering design. If you don't understand the impact of that design change downstream, whether it's ops, whether it's, from a CapEx perspective, there's a ripple, right? It's the butterfly effect. And the more cross-functional you are, right? And as engineers progress, they should continue to go outside of their comfort zone, right? You should be talking to the mechanical teams. You should be talking to the compute folks, executive leadership team, because all of those things actually play into what we do. And the more knowledge you gain, the more you're curious, the more effective you're going to be in your core skills. On submarines, there's something called the law of the conservation of happiness. So happiness can neither be created nor destroyed.
Okay.
It can only exchange hands. And so when the hatch goes closed, there's actually a finite amount of happiness on a submarine. And so the only way to become happier is to take someone else's happiness away. It's a very sick game, but it's, and we joke, but,
Right.
It's just, the close confines of, being on board a boat.
Yeah. I couldn't even imagine. On the one hand, it seems pretty cool, but I'll bet you I don't know what it's like in the in-between moments. Like the closest I got is, watching Sean Connery at the deck and, trying to avoid his country and the hunt for Red October. And
The Scottish-Russian captain?
that's exactly right. I don't remember what he was eating in his cabin the one day I was watching it, but I wanted it, whatever it was. It was so funny, and I was a big Tom Clancy fan back in the day. But yeah, I love that show. But anyway, it would talk about, it made it seem like it was this constant, exciting moments. But I got to imagine, like,
It's not.
Yeah.
The thing is, it's like what we do today, right? There's hours and hours of boredom followed by minutes of excitement.
Right.
And you forget about, because we as humans, you remember the most painful things and you remember the good things.
Right.
But anything less than those, it all turns gray.
Yeah.
And for me, at least, the good, vastly outweighed the bad. I also got a lot of good deals. I knew that it was time for me to get out because, there's a finite amount of luck too.
Right.
And so it translates very well to what we do today because although we're moving at a much faster breakneck speed than, I'd say years past, but I don't necessarily see that as a bad thing.
Right. Well, let me ask you this. I have a lot of friends that have been in the Navy. They either taught Navy nuke school. They've been operators, plant operators, officers enlisted. and when you were speaking earlier, one of the things you emphasized was, look, safety. These are the things. This is, by the way, nuclear material. We're very serious about what we're operating here, and we're going out into one of the harshest environments known to man, as harsh or harsher than space. I had somebody on from Saab once, and they were in the underwater robotic division, and he said, we have the moon mapped better than we have our ocean floor. So you're taking this boat, and you're going to do all of that. And oh, by the way, we have people that might not be our friends out there patrolling as well. And at any moment, you may be called upon to take significant global historical action. So my experience with people that are serious sailors is that they take that very seriously, all those components. And I'm not saying in critical infrastructure we don't, but one of the things you've mentioned a few times is not just understanding sort of the list, like I know this shape goes into that hole, but why? And what's the butterfly effect? And I'd love for you to we talk about high availability. Some people in our industry, again, whether you're on the IT side or you're on the data center construction side or whatever, we talk about the nines, 5 nines, 3 nines, which usually means 99 point some number of nines later, which supposedly implies how resilient a system may be. And I've heard you speak before about, I don't know that people always understand, first of all, what's the real value of the nines, or what is it implying? What's the result? So if you tease that idea out, not necessarily from a Navy perspective, but just as you think about the critical infrastructure world that you're involved in today and designing, building, operating, maintaining data centers, what do you think we're not getting right, or we should think about differently? Or maybe we do, but it's just there's an idea you want to tease out there.
Sure. I mean, I always, when talking about availability, it's like explaining, where babies come from to children.
I didn't think that's where we were going to work. Nuclear plants and reproduction. I like it.
I mean, to be honest, sometimes, the higher up you get, the less you understand about availability. So sometimes it's...
I take it back. I can now see why you're from Buffalo. That cold air can really... Actually, not Buffalo proper, but near Buffalo. I'm sorry. Keep going.
No, it's the idea is our industry has also evolved, right? And so if you look at the utility space and power availability for years and years and years,
So pause right there. For a lot of people, they may not know when you say utility space, what does that mean?
Sure. So I'm referring to the electric, what everybody thinks is an electric company, right?
Gotcha.
Where power comes from.
Sure.
And, most people are obviously connected at distribution, split phase. So everyone knows that when they turn their light switch on, the light goes on. Mm-hmm. When they turn it off, the light goes off. We have never been in a scenario where when you turn that light on, well, maybe except for California, the light may or may not go on, right? And so for most of everyone's, near memory, that was an unlimited resource, right? We took it for granted. Our industry has done the exact same thing. If you think about essentially from 2000 on, power demand has stayed flat because of the increase in efficiency in various industries, right? From a CapEx perspective and OpEx perspective, there was a reason for people to make investments, LED lighting in, commercial buildings. People saved a ton of money, right? So there was a fiscal incentive for people to improve in efficiency, which resulted in an excess of electricity for the most part. Data centers over the years have had easy access to that. And if you look at the difference between transmission, right, the big metal poles, versus distribution, which are essentially wooden poles. It's the easiest way to talk about it. Most of the large-scale data centers are connected at transmission. When a transmission line goes down, it makes the national news. When a distribution line goes down, it doesn't, because that's actually how the utility companies maintain them, is they run to fail for distribution. They don't do that for transmission. So if you look at the way availability comes, most of the inherent availability in a system comes from the stability of your utility, your incoming utility line. And so I would argue that most co-location providers that aren't hyperscale and may not be connected at transmission have had a tougher time in design because they've had to witness more outages than your typical hyperscaler. And so when we look at availability, the number means is that essentially that service that you're providing to somebody is not available, right? And most people mean that in the way that, power has gone away or a mechanical failure. Some failure has resulted in that going away. One of the other aspects of availability that people don't remember is if I have to move that service out or I have to take that service down because I have had a failure that I now need to shut down the equipment to repair, that isn't considered unavailability, but it affects the business in fairly significant ways. And so when you look at availability, most people, especially the hyperscalers, pat themselves on the back and they say, look how good our availability is. And I say, yes, because that transmission line that you're connected to hasn't gone down. And it won't go down because people are actively doing maintenance to maintain it. If you took that same data center and plopped it onto a distribution line, that system might not be nearly as good as you think. And as our power grid gets more constrained and we potentially start seeing more outages, you're going to start seeing some of these inherently, I wouldn't say poor designs, untested designs. They might start seeing the challenge of concurrent maintainability or, hey, I'm opening every breaker because I just assumed that it would close, right? Every action has an equal and opposite reaction. And every opportunity for a piece of equipment to fail, the fewer opportunities you give it, the more reliable it'll be. And that's inherent where you see this availability. So as our power grid becomes maybe less and less predictable, or I'm running on turbines or reciprocating engines, because we can't get power anymore, it's going to change how people design data centers because the habits of old and the designs of old aren't going to necessarily give us the ability to hit those availability targets, the 5 nines metric that everyone uses. But remember, it's also not that availability SLA that often matters. It's a mean time to restoration, right? So I can have a failure if I have a system that allows me to bring that service back online quickly. If I don't have that, right? If I don't have that backup system or I don't have that alternate path to provide power, or I don't control the failure effectively, that's where you start getting into challenges. And so as you start getting on-site generation in addition to utility, in addition to battery energy storage, in addition to, these systems get more complex. And if you don't understand that interaction of subsystems to the larger overall site, you're going to have challenges. The other thing, and this is, if we touched on anything, the thing that our industry does the poorest job of is recognizing that people matter the most. Almost half of our outages in our industry are due to human error. And yet we focus so much effort on reducing other factors. But you think about it, it's, hey, I didn't put automation in here, or the way that we designed this because we have 16 of the different things, and so the operator had no consistent, interface. People are the reason why we have outages most of the time. And if you don't recognize that, it's hard to challenge it.
But as these systems are now coming under stress, whether it's we do microgrids or we get much larger power out onto the floor, not we're not stepping it down in medium, we're bringing it out because of the size of the power we need in the racks or whatever. Like, if the designs are not put through that stress test and constant, not just digital twins, but constant evaluation, we may end up in a circumstance that you're talking about.
Well, so I have a phrase that I use. Complexity can neither be created nor destroyed. It can only change phase. So if you think about flying an airplane, the complexity of flying an airplane used to rest inherently with the person, the pilot. As we've added larger planes and, the human couldn't do it with pulleys and wires. And so as you've added complexity, or as things have evolved, as you extract automation, that automation needs to be created by people that understand the system and they understand how it's going to work. And what, myself and one of my colleagues, Tom Blooming, that I used to work with at Google, he and I were one of two engineers. Actually, we were the only two engineers that sat at a data center for almost a decade. All of the other engineers sat in Sunnyvale or in New York City, and it wasn't necessarily by choice, but we just happened to be at the data center. And we found that it was almost like a superpower, because we got to actually sit and talk to the ops folks every day and ask them what worked, what didn't, what, they would complain, we'd see what was broken. And so I came from an operations background too. So I always designed my equipment, my systems, with the understanding that I might need to operate it. And so when you think about how some of these systems get designed, is, my biggest advice would be to involve the ops folks much sooner in the process. You'll find that, at least from my perspective, that understanding and how to build a system that provides the right inputs to an operator, an engineer sees the world differently than somebody who has to operate the world. And so recognizing that blind spot, I think, is a key factor. You had mentioned, hey, how do you do this? There's an approach to it where it's like, would I want to use this? What information would I need? So, we designed, I'll give you an example. I have a very particular, it's almost a religious discussion when we talk about certain things. One in particular is displays and lights. One thing that I typically do, medium voltage relays or lighting. If I have a panel and I walk into a room, I don't want to see a Christmas tree. A light should be illuminated if it's in an abnormal state, right? Maybe you have breaker status or stuff like that. But if I look down a medium voltage relay, if it is normal, I don't want a light. I want to be able to look in a dark room and see at a glance. And right, so from an operator's perspective, if I've got a dynamic event going on, and if I've got all these lights and I have to actively look at something, right, you have to think, hey, how am I doing this? You talked about MOPs and stuff like that. It's just, the world are systems, and so I'm a systems engineer, so I'm plugging that a little bit. But for me, the most successful people are curious. It's hard to teach curiosity. I mean, I think you can, but you have to show people the benefit of being curious. Curious people tend to question the why. And so if anyone that's ever done an RCA, right, you keep asking.
What's an RCA?
A root cause analysis, where you essentially, a failure occurs and you look at the timeline, you see what happened, what can do differently, what was triggered,
Can you replicate it?
Exactly. Corrective actions, long-term, short-term, mitigation, all that stuff. But people who are good at those understand all aspects of things. And so the more broad you get, the more opportunity you have to essentially discover your ignorance, the more effective you're going to be. And anyone that thinks that they're not ignorant is ignorant.
Married?
Well, they are ignorant, right? But it's that willingness to look like an idiot,
Right.
that makes you not the idiot later.
Right. Let's pause there for a second. I'm curious. So how do you recruit for that? Like, not just how do you develop, but how do you interview and recruit for like that material? It doesn't have to be fully formed, but you want the ingredients there.
I actually have. We had talked about this in the pre-podcast part. I have several interview questions that I typically always ask. One of them, and I'm going to tell you how the sausage is made here. Okay. So, one of them in particular is I say, and there's various forms of it, but it's, hey, you are in charge, or for the day in your current role or your current, whatever it might be. What would you change about it, and why? And it's a completely open-ended question that there's no right or wrong answer. Well, I take that back. There is a wrong answer. The wrong answer is, I've never thought about that before. Like the person that like you can see them lean forward and like somebody has asked me, they've been waiting for that opportunity. They've been thinking about this so long. You can see that fire. You can see that curiosity. I also will dig down on a technical level to a point where they don't know what the answer is. And it doesn't matter what it is. I will actively seek it because I want to see how they'll respond to not knowing the answer and see the thought process, right? And the person that they list through all of the places they'd go look, or they, you can see their mind working through, kind of how they would solve it. They don't know the organization. They don't know anything, but just watching that thought process, you can see whether somebody would be curious. And it's like, if the answer is, well, I'd ask my boss. Okay, well, what if your boss doesn't know, right? And those are the sorts of questions that, it's fairly easy to understand a good answer, and it's easy to understand a bad answer. But I couldn't tell you, you would probably perceive it differently than I would, but we would both recognize what is a good answer.
Right. So as we're talking about availability and the, where I'm fascinated with this is the people that have the ability to be curious, and it's almost like there's a way to ask why. I have found when I was in the Army, I had Velcro on my stripes because I had not yet mastered the art of why. I wish I could go back to that kid. He probably wouldn't listen anyway. But if I was like, why? Disrespectful, arrogant, argumentative, probably not. I can just tell you from personal experience. I don't know how they did in the Navy, but I got introduced to wall-to-wall counseling. It was a regular routine. And if there is, if your cadre or your leadership or whatever has the opportunity to sort of, I encourage the why. And it really is curious, not like, well, why is that? Could that work differently or whatever? Up until your commander says, we're enough with the whys today. We're moving forward. This is what we're doing. Like there's a balance in there. And I when you started to go down the path of, it could be taught. I think that's also part of the art. One, that you have that mindset. And the other is, I need to be curious. I need to be thinking about this. Is there a way without it either being arrogant or, and that looks differently for different people, but it's genuine curiosity. But at some point, soldier, here's the deal. We got to take that bridge. We got to do this thing. We got 10 more minutes. We're not out on the range. We're on a mission. I got to take care of the troops. I got to accomplish this task. I got enough whys answered for today. Let's go. So how do you balance that?
Well, that is the why.
Okay.
So what you just gave at the very end is the first why. Is sometimes you have to take people out of the rabbit hole that they're running around underground and they don't actually see where they're going. right? They're going a vast, far distance,
Right.
but they don't actually know where they should be going. And so when you talk about that why, then maybe you just need to step it back. And typically, what I like to do is I never discourage that, right? And I always explain the why. It drives my wife nuts. But part of it is, to me, by me explaining the detail that you might not have asked for, I'm explaining to you my thought process or the reasons behind it, so that you read the summary, right? But I also have detail underneath that, I'll often link to it, right? And so I'll have the TLDR, the executive summary at the top, and then I'll have the full technical detail. And if you link to it, the person that wants to know, you should always have the answer in there so they don't have to ask, ideally, right? If you're justifying a decision, all the data, all the, the justification, it should be digestible to the audience that you're giving it to, too. And so making sure that you understand their why drives your why, right? And if you have a leader that is not capable of explaining the why, then I would question why, this is going to sound funny, why that why matters. Right? Is it should be something that is easily understood as why it's important, right? And if there's some nuance to it, right? It should be something that should be able to be explained. And if not, then you have to figure out, ironically, the why.
Right. Well, we started off talking about the nines. I'm curious, to whatever degree you can share, especially lately, have you seen or experienced where we in our industry have a false set of confidence? I have some algorithm that says, well, I'm concurrently maintainable or whatever it is. And my design's been tested like this, and I've got it on stamp mode. I'm repeating it. And perhaps I'm not taking into account the things that are changing. I'm not connecting to metal sticks. I'm connecting to wooden sticks or whatever it is. Or even more interesting and provocative, I'm not connecting to a utility. I'm doing this myself, whatever these various components are. And there's a lot of change and disruption going on in our world today, at least hypothesized with the evolution of GPUs and that infrastructure, or even the new CPUs and that hybrid environment. So there's a lot going on that are testing sort of a pretty steady eddy in industry design, where we could incrementally watch the growth of if racks were 3,500, 3.5 kW 3 years ago, we know in a year they're going to be at 6,000. And now all of a sudden we're like, no, they're going to be 40 kW, 140 kW, 600 kW, whatever it is that we keep getting told by the game people out west. But these are the things, and we're trying to solve for them. Have you seen it where you're like, this is going to go sideways, this is not going to go well?
So the issue that we run into is the lead time for our infrastructure does not match the cycle time for compute.
What does that mean?
So NVIDIA just had their GTC conference, right? And Jensen was on stage and he announced the 600 kW Kyber rack.
Right.
Well, the only thing that I thought when he announced the 600 kW Kyber rack was, okay, what about the rack 3 or 4 years from now that I am actually building for today?
Right.
Right. And so most people, if you think of our industry, the tail wags the dog, right? Is the design comes about as, hey, we want to deploy X widget that consumes X power. So now we're designing today for that product that is available today to deploy in the future. By the time we deploy that, that's no longer the current product, most likely. Right? And sometimes they are, sometimes they're not. And so that cycle that we in our industry do is slightly different than others, right? Just in time, right? COVID exposed, just in time, manufacturing and stuff like that. But our industry could really benefit from some of those lessons, right? Where you have capacity in flight, where you've standardized your design, right? We touch on modular, right? This is where modular in systems matter, because then I can take, if I've done my modular design correctly, if I've thought about capacity and the ability, okay, maybe it's 2,000 amps today, but next cycle, if I've designed it properly, the only thing I have to do is upsize this to 3,000 amps. If you understand how these systems work and how switchgear or mechanical or networking and you design it in such a way that it's upgradable, or they are modules, right? Then you can actually adopt things quicker because I don't have to wholesale change the design, right? Same thing on the building side. How do I build this faster? How do I accelerate buildings? We've always done, most of it is linear, right? And as you get to, and you break it apart and you make not start to finish, where I bring in temporary power so I can commission things in parallel, or I commission things off-site or remote commissioning. It's one of those aspects of our industry that we're a little bit behind on, is that you don't see prospective designs in data centers where you say, you know what, I'm going to put more capacity in this design than I think I need. Is it cost more? Yeah, it could. It could get expensive if you misjudge. But I have yet to have a design where we went smaller.
Right.
And yet every design they want more.
Right.
Right. And so if that cycle time, if you know it's a 18 to 24 month cycle, and you can look at the historical, hey, we needed X amount more.
Right.
Well, today I should be building X amount more for today, because by the time it's ready, I may want that.
Right. Do you think that's is an interesting thing I've heard you say before about, at least in our industry right now, there's still a lot of bespoke instead of, if you look at, for example, material handling, one of the most fascinating things to me, they've so automated receiving infrastructure from the logistics entry point, loading dock, whatever it is, getting it out into their floor at some point, usually automated, not always, but usually, but they got a process that's pretty simple and elegant. They've got it inventoried, usually through a tool, not necessarily AI, but they've got a, because I've been doing this for years, they got the ability to sort of stack it up and organize it and inventory it, and whether it's the people or it's the machines can go get the thing, and it's managing parts inventory of, when this order is placed and it's dropped in a box to be shipped somewhere, it knows what's left in that crate. And, it's soup to nuts. It's also doing an evaluation on mean time to failure, either by the boilerplate that the manufacturer said, because it's tracking the cycles, or more and more we see cameras coming in and looking, and it's saying, we're looking at the wear and tear on this thing, and it fits this algorithm. Like, it seems like they're really thinking forward about, how do I take the human brokenness, and I'm going to move the humans. Well, because what a lot of people are telling me is, oh, great, now the humans are losing their jobs. They move into different things way more often than not, or the scale's getting such that they're not using less people necessarily, and maybe per ratio. How do you... Is that right to be thinking that our industry is still bespoke like that? And do you think there's an opportunity for us to get more automated?
Well, let's think about what's causing the most delays in building data centers today. What are you waiting on right now? Transformers, generators, switchgear, breakers,
Power,
right? So these are all things that are 18, generators. If you get something under a year today, you're doing good. Right? Transformers, if you get it at all, you're doing good. Right? But the question is why? Right? Manufacturing for automobiles, they can scale up or scale down. They get new designs every year and they crank them out by the millions. Right? Microelectronics, your phones, your tablets, all the widgets. Why is it that they are able to accelerate their build cycles, and yet our industry's build cycles are lengthening? Typically, when demand goes up, right, then the manufacturing capacity will increase to bring the demand back down to some nominal value. Our industry doesn't have that elastic capability that you typically see in other industries. We don't have automation, right? Why am I waiting 2+ years for a transformer? Right? Now they're large scale, right? Same thing with engines. But if you think about the way generators are manufactured, you think about the way switchgear is manufactured, it's still a very manual intensive process. There's no automation being applied to it in the design cycle, in the manufacturing cycle, in the testing cycle, right? I go to commission. Every single script that we do, maybe it's on an iPad, but it's not automated. It's still a human triggering every single thing, checking the box. And yet, how many months are we delayed to get SCADA up and running? All that information should be available, could be designed in, right? The way they design car subcomponents, they have jigs that they can go set it on and validate that that subsystem works properly. Why isn't our industry adopting that same technique of splitting them into subsystems, validating the subcomponents, the interface between other things, and saying it's good enough?
Why do you think they aren't?
It's the way we've always done things. And right now, because there's such a demand to get things built, the optimization isn't something that people are spending money on because they're focusing on the CapEx. We've been building, and our industry is still fairly young, if you think about it. Earliest, what we would consider to be true co-location data centers, early 2000s?
Yeah.
Probably.
Yeah.
So they're at the 20-year mark. None of them have reached a refurbished stage where you have to take the equipment out, upgrade, right? So we're so young that those painful cycles of refurbishment, replacement, once you get to end of life for the infrastructure equipment, they do a very good job on the compute side. But that pain of designing in a way or understanding the impact at these full life cycle hasn't been something that these industries have really had to consider yet. And so when you think about that, how do I quickly replace something? They don't necessarily care, right? They don't design it to be replaced quickly because they don't think that it's something that they need to care about because they're more concerned about getting it out the door day one, right? The CapEx spend. Does anyone ever ask, how much is my OpEx going to be for this design?
I could think of times that they do, but
But it's not normally in the, right? When you get presented a design, the question doesn't say, what did ops think of this?
Right.
They'll ask ops, hey, will you sign off on this?
Right.
But ops wasn't a part of that design cycle where they say, why would we design it like this?
Right. Well, we're a little, I 100% understand where you're coming from. It's a little bit different in our world. Some could argue with that because we're a design, build, operate, and maintain group. And their emphasis, we have architects, but the large firm of architects are who we contract with. But our operators and it's a little bit different. I think it's almost unfair because the way that I would answer it is probably out of the norm for most organizations. But I completely agree. And we went through that very painful experience in our early, probably first 10 years. But the emphasis was on our IT world. And the experiences that we learned with the relationship between compute, network, and storage before there was ever pressure from a data center infrastructure, we weren't thinking about at the time stranding capital or, I had a 5 megawatt UPS infrastructure over there that we could imagine running for 10 years to the end of life. And so as we began experiences through the IT pains of the 90s and 2000s, those same people in our same leadership were able to say, so how do I apply this to trying to be a fast follower? And we tried to distill it down into Legos. I know this is not a great analogy, and I don't want to make this infomercial.
Everyone uses it.
Okay, but I don't want to make it an infomercial for us, and certainly there is room for improvement. But I know, so I want this building to make it a couple hundred years. I don't want it to make it 10 years or 20 years or 30 years. And it's a fully operational Death Star. So, how am I going in to whatever? That's what makes liquid cooling, for example, now such a challenge. It's not just the densification, because in the past, I wouldn't put UPS on mechanical. I would only put it on compute. And for the longest period of time, we were trying to work UPS out of the design because the resiliency wasn't 2 or 3 pods in a single physical data center. It became a pod in 3 regional data centers, which has become distributed across 20 data centers up and down the coast or across the country or whatever. And so just like that utility example you're giving of not just flat, but in some ways decreasing, it's so very manageable and easy to do. And not just in the last few years, but we began looking at this, like, how do we do a system of systems? How do we apply these lessons learned into design, build, operating, and maintaining these things? But now we've got to go to supply chain and say, what are you doing to do these very same things? I need to switch out nobody would think about switching out a COD board or something like, how would you do that? And then lastly, I would say, Luke, what's been interesting is we've had people from parallel industries or adjacent industries. I'll make one up. The Bird's Eye frozen food people coming and say, well, you need cooling. We've mastered doing it like this with these open air things. It's a completely different supply chain thing. We're like, yeah, that's cool, but you don't have critical components in your control board. So we could never get that. Like, it's almost like, yeah, I love you want to give us that SUV to drive across a desert, but you haven't reinforced the welds, so I couldn't do this. But I like what you're thinking. Think about another way to do it other than a Land Cruiser. It could be this other thing that we're not thinking about. But it is certainly a cultural thing because it's the same way we've always done it. And we're all sort of reeling from the last 4 or 5 years of scale and speed.
Well, there's a couple of things that terms that I use. There's something called design for construction, where you design it in such a way that you can actually build it, right? How many times have you had the GC or the electrical or mechanical sub or the fiber sub involved in designing it and ask them the question, how can I build this faster? Has anyone ever actually gone to...
I'm not going to answer that on air. I don't want to give away secret sauce.
Well, maybe you guys do, but in my experience, it's not something that happens very often.
Yeah.
And yet that's where you lose the most time.
Yeah.
Right? How do you avoid the change orders? Right? How do you avoid the delays? The people that know that best are the ones that do it. Mm-hmm. Same thing. There's another term that I use. It's called design for maintenance. You know that maintenance is going to occur. So if your system doesn't account for the major maintenance scenarios or failure scenarios. Now, if it's a conscious choice, that's one thing, right? If you say, yes, we understand and we are willing to take the risk, I have no problem with that, right? It's the absence of thought from the very beginning, right? If you've got design for operations, same thing. How do you ensure that you can have sublinear headcount growth on a larger scale data center, right? People tend to be the most expensive thing from an OpEx perspective after the fact. Yeah. And so if you don't design your site to operate with the minimum number of people effectively, you're essentially shooting yourself in the foot.
Yeah.
And so if you think about these things as you go through it, right, design for construction, design for maintenance, design for operations, now you have your full life cycle. If you prioritize those from a leadership perspective, right, maybe speed of deployment is the most important thing. Communicate that. Then construction should be arranged for speed of deployment. Same thing, your operations team should be there as part of commissioning so that they can transition to operations faster. There needs to be a hierarchy of needs as defined by your culture. And they're going to be very similar, but understanding and making sure that people have a basis of design. You should, as a company, say, this is how we do business. This is our focus. This is what we're designing against. And when I or my team needs something, I shouldn't have to explain it to them.
Right.
They should be able to recognize what the priorities are. And, I as a leader or, as a mentor or individual contributor, I should be able to say, hey, I don't think this aligns with kind of what we were trying to do, right? They should be able to self-prioritize based on what the business need is. We go back to the why. Everyone should understand that why. And that, we're chatting about how do you be a good mentor?
Right.
That's, to me, if you can walk away from, mentoring somebody or having a conversation with somebody and they now understand the why, that's what you've done.
Yeah.
And that's enough, right? That explanation, that understanding, now they don't have to come back to you.
Right. I love in the military. I'm very lucky. Not only do we have a lot of vets, our current CEO, don't hold this against him, is a West Point grad. He's a construction guy.
We all make mistakes in life. Some are just bigger than others.
One of the things we spend a lot of time talking about is commander's intent, which I know you know very well. And the idea there is, for those who aren't familiar with it, I have the Uniform Code of Military Justice. I got the Geneva Convention. I have a mission, and I got to take care of my troops. And so here's the deal. And to the degree that I'm able to, without compromising the integrity of the mission, there are degrees of knowledge. But to to the degree that you can understand your why and ask those questions of your commander. What's our mission overall? What are the rules of engagement? What does that look like? Well, now you have a lot of freedom to go exercise the mission. I was listening to somebody on a different podcast talk about fog of war. They said, there's this really interesting thing about fog of war. So when it comes in on you, to the degree you understand this is the commander's intent, and this is what we're trying to do, and at the squad level, at the team level, and all the way up, depending upon which branch of military you're organized, not only do you have a much greater opportunity to complete your mission, but you can safely, look, this is beyond our parameters. I need to pause here and actually communicate with somebody. I think the command and control of the United States is good or better than anybody else on Earth, but that's one of the things that we concentrate on. But when they were talking about the fog of war, they said, so on the one hand, commander's intent really serves during that fog, but when you look back later, when everything's done, there's no fog. You see the path that was taken, but the fog's clear. Now you just have a result, a history of it. And it's interesting to see when... it's almost like when you blindfold people, you can see all obstacles, but you map them, kind of working to solve the objective or whatever, and who works through that and how do they solve it and whatever. It's fascinating conversations.
There was very early on in my career, one of my captains said, and it's fairly common in the military, but one of the big things that has stuck with me and doesn't necessarily translate as well, maybe in tech.
Hockey's a confusing sport?
No. Puck goes in net,
Okay.
light goes on. It's how you phrase things. I intend to versus asking for somebody to give you approval. I want you to tell me no. And what it does is it shifts the ownership, right? If somebody comes to you, a junior engineer or somebody on your team, you don't want them bringing you problems. You want them bringing you solutions. When somebody says, what do you want to do? That means maybe they've thought through the options, but they're essentially asking you to tell them what the answer is. I would much rather have somebody try to understand my why or the whys that we have prioritized and come to me and say, based on my understanding of what we're supposed to be doing, I intend to do X. And now I have to, if I disagree or if I think there's different, then we have a conversation. But it's about ownership. In when I say I intend, it's I intend to do something. I am taking responsibility. When I ask you for your permission, I'm putting the responsibility on you. For a team to develop and to take that ownership, right? Everyone says they want the teams to take ownership. You can't take ownership of something if you have no authority.
Yeah.
And so that's where you see high-performing teams is that a good leader, essentially, they should not be needed. And they've essentially trained their replacement because their teams are so high-functioning that they have communicated effectively, and they've given them the autonomy, right? Sure, there's mistakes. Sure, there might be missteps. You might need to redirect them. But if you go away on vacation and you come back and you don't have any, nobody's had any problems, right? Then you've done your job to the best of your ability.
Right. Yeah, I think I completely agree. Do you think, so where we were starting with this, is for an operator like us, so we're not the customer. I argue all the time, data centers are the most valuable real estate on earth. Like if the ideas of the whole world are in a data center, it's pretty valuable.
Just remember, all the private equity money that was in commercial real estate, where is it now?
Yeah. Well, and where's the antidote? Where is the sermon? Where's the musical thing? Where's the memories of your heritage? Whatever. They live in a digital form, which means ultimately they're going to live in a data center. So operators like us would talk to our customers, whether it's a hyperscale customer or one of the Fortune 2000, and in a lot of ways, we're fast followers. And so as they're communicating to us what they want to deploy, what their why is, how they want these electrons to go to work for them, how we need to, and they may not have it all solved, but like this is what I'm trying to accomplish, whether it's in a 600 kW rack or something less. this is my risk tolerance. If they have it defined, they don't always have it defined.
Most of them don't.
Well, what I found, Luke, is there's inconsistency across the groups. The executive level will say, this is our risk tolerance. The IT folks, whatever, you know the drill, the various forms. And so it's weird. We rarely get this really nice package. We either get way more resiliency than they actually need. And if we try to go demonstrate, look, a tier 2 deployment with really good preventative maintenance is going to be much more statistically available for you than a concurrently maintainable with a so-so preventative, rigorous maintenance program. But whatever it is, you have these inconsistencies. So we work to do that. But ultimately, whether, in 10 years ago, there was a lot of conversations around PUE, or as my guests I toured one day said, what's your POO philosophy? They didn't understand it exactly. But the point is, customers will come to us and say, this is what I need to solve. And I'd like to think we're pretty curious and say, okay, here's do you want speed? Do you want accuracy? Do you want cost? Like, how do we do this? But as I've teased, I don't know if you know Dean Nelson. I've teased Dean. I'm like, Dean, which Dean am I talking to? Am I talking to Sun Microsystems or eBay and Uber Dean? Am I talking to modern Dean? If I had said to you as a principal engineer, no, I want to give you this. You don't need 3 to make 2. You don't need any resiliency over here. You just do it. You'd kick me out. You wouldn't let me bring a design to you, no matter how curious and persuasive I would try to be. So how do you educate your executives to have this mindset? I'm curious at whatever organization you're in. And how do you have a team that is, look, we still got to get a job done. So we want to be able to articulate the problem we're trying to solve so that the operators like us can provide a solution for you. But sometimes you just got to go. Like my customer said, this is what I want. I want 3 spare tires. Just go do it. Bro, you're just driving to Buckhead. You don't need 3 spare tires. But I'm not going to win the argument.
It's funny. That's the same challenge that I've seen my entire career is that, I'll give you an example. I firmly believe that data centers have negative availability impacts from deploying diesel generators. What
do you mean by that?
If I were to take the money that I had spent, and it may change as the grid becomes a little less stable. If I look at the money that I spent to buy diesel generators for, a data center build, if I were to take that same money and go to the local utility or the transmission utility and say, I'm going to give you this amount of money to bring me a 3rd line or I build a 3rd path, I would be willing to bet that your availability would be higher by not deploying diesel generators and strengthening, essentially, if you understand where availability comes from. Now, certain areas, certain things, absolutely. Diesels, are there.
Or whatever
your
just
backup.
the generator,
correct.
Right.
Yeah, whatever you're going to do.
Right.
But the one-size-fits-all scenario doesn't leave room for innovation, right? Same thing, right? You guys often build to a spec provided or a common spec that most of the hyperscalers could use. But it's like walking into a restaurant and telling the chef in a Michelin star restaurant how he should be cooking the meal, right? I see a menu, I want, whatever it is. Are you going to go up to the bartender and tell them how to make your drink, right? I want a mezcal Negroni, well, I might tell them, but but that's tech, right? Is we think that we're smart enough to know how to do it. But what would be ideal for you is if somebody were to say to you, just give you an SLA, give you your power, and they tell you an inlet temperature and an outlet temperature. That should be enough.
It should be. So, because what we would do then, back to the PUE conversation, when that began showing up first in RFIs, then RFPs, then if you don't have a real path, regardless of what we feel about it, if you don't have a real path, not just blanking panels, whatever, to get to some measurement, APIs where I can interact with your system, we're not even going to talk to you. And then we pressured the infrastructure providers for us to give us the ability to, even in a multi-tenant world, to demise data off of a common RPP or PDU or overhead bus, or whatever it is, these different components that didn't exist for years before because that end user said, we're not doing it. You got to do it, or whatever. How do we, I guess my question is, and I'm not trying to pass the buck, but how do we then influence the switchgear makers? Because when I talk to my, friends over at MC Dean or whatever, my modular people, they're like, for the last 10 years, I can build you infrastructure, chiller infrastructure, CDUs, whatever, electric rooms that are plug and play. Snap them in, use them for a life cycle, unsnap, snap in the new components, or connectivity for my connectivity friends or whatever. But because there's a cost, or maybe even there's a complexity in developing that method or procedure to make that happen, or there's a speed element in order to build that line. It's not fast enough, or it's not affordable enough, or whatever. So how do you break that barrier where you get people that want to innovate and deliver?
It comes down to money. I mean, ironically, is if you look at where most of our infrastructure goes outside of the data center world, it's the utility space, electric utility or industrial space. They don't adopt new technology. They want consistency. They want to be able to buy the same thing because the one they're replacing is 40 years old. And they don't want to have to redesign the system. So if you look at where that money comes from and what drives the designs, it's that longevity that drives it. They don't want change. So right now, we as data center customers are actively buying things that aren't designed for data centers, right? We're taking an existing infrastructure, domain, and we're applying it to what we do. So if we wanted to do things faster or do things differently, we would ask or demand from a manufacturer where I say, I want something where I can order the shell up front. My footprint is exactly the same. I can design the building, right? You have to think about design for construction, design for maintenance, design for manufacturing. I'll give you an example. We actually deployed a full IEC 61850 digital switchgear design.
What is those?
So IEC are the standards in Europe that apply. They would be ANSI standards here in the United States. This one refers to, it's just a substation protocol language. It's used for both automation and protection. It'd be like Modbus or for other scenarios. But traditional switchgear is hardwired, right? All of the signaling, all of the interlocking, you go through various parts of the switchgear to pick up status.
Right.
We opted to go fully digital, where everything went into a relay and then communicated it out. What it actually did is it actually reduced the complexity of the manufacturing. So instead of having a whole bunch of wires going back and forth requiring skilled labor, right? So if you think about within a factory, you have different technician skill levels for assembly. If it's a simple panel, your junior person can do it. If it's a more complex panel, so if you have a lot of complex panels, you don't have a lot of people that can wire it. And so therefore it takes longer to manufacture. So if you simplify essentially the way your things are constructed, it gives you the ability to actually manufacture, test, and deploy your equipment faster. Very few people think about, hey, how many wires am I asking, right? They don't think about, how can I make this easier for the manufacturer to build it? Because then if I've saved 4 weeks on a delivery, right, that's real world revenue acceleration.
Plus the rework.
Correct.
Like 20 to 30% of any build is rework, or I delayed the mechanical because the electrical got interrupted and I can't.
Or I delayed the electrical because I didn't have any cooling.
That's right.
Right. And so this is the scenario where people don't necessarily think through the full impact or, hey, could I do this differently to accelerate something else? Right. And so that's where when you think about, people talk about modular all the time. Modular today, the biggest reason to go modular is because you can't get on-site labor. It's not that there's a massive advantage. I mean, there's plenty of other advantages. The other thing that people confuse is modular is not cheaper. It never has been.
Right.
It never, well, I won't say never because I've been proven wrong by saying never.
It's uncommon.
It will eventually be if you standardize and you figure out a way to do it.
Right.
But right now, the reason is you can't get labor, right? So the only way for me to accelerate my builds at a higher quality is to do it offsite, right? And so there are reasons why modular works and why it can be, and if you test it appropriately, but it's our definition of modular in our industry is very different than what you might see in an automotive industry.
Yeah.
Right.
It's hopefully it's one of those words and one of those phrases. I think you're exactly right, but that we standard, which is why we went to ITIL decades ago. Like if we say change management or patch management, we need a fixed point of reference that we all agree. When we say change, that's what it means right there. It means this thing. When we say release, this is what it means. It's not my definition. It's not your definition. We've standardized on this thing, or you were talking about some of the standards earlier. I think modular needs to sort of, what do we mean when we say modular? I was talking to somebody the other day about modular, and my buddy Tony Grayson, also another sub-commander. When he talks about modular, there's a lot of overlap here, but not everything. And he means containerized.
That's different. Containerization is not necessarily modular.
That's right. But we use that word modular, and there's elements of agreement in there, but it can confuse people that aren't close to this. Or they're like, well, I don't know what do you mean by that? Somebody was talking to me about their modular, I want to call them GBICs. That's going to date me. But they're components in their fiber infrastructure. When you were describing this, it reminded me of two things. A good friend of mine out of Maine makes modular homes. I was like, so I heard manufacturer home, not modular home. And he said, no, bro, here's the deal. I can make a Hurricane Cat 5 home. I'm going to build the entire frame in my warehouse. You're going to go get your pad ready in Colorado or wherever it is. And it's not necessarily faster, but this is and it's definitely not cheaper. It'll be the same or a little bit more expensive on the capital outlay. But here's what the advantage is for you if this fits. When your pad's ready and you say go, and my infrastructure shows up in less than a week, it's fully together. And the integrity of that structure compared to a standard stick build, whatever, there's no comparison. Well, what about move add changes? Here's how we've perfected move add changes. And oh, by the way, you imagine you're losing something, but I built this in a climate control warehouse.
Absolutely.
Not out there. And you didn't have to, do you know what your loss is from just materials on property that either walk away from the site or you've got to manage space for it or what? Like, here's all the reasons. I'm not saying it fits everything. And then the other one was my kid, I don't know if you noticed this, but used cars cost $1 gazillion now. I've bought 3 for my college-age kids, 3 cars in the last 18 months. I'm still driving my 2015 F-250 out there. And so I put the new, whatever you call it, stereo in there that's got the backup camera and all the things. Thank you, God, for Crutchfield. Because when I was a kid at 20 or 22 in my crappy 74 Camaro, when you open the doors, they hit the pavement, and I had to put a stereo in it. I'm soldering stuff. I'm shorting. I don't ever think my right headlight worked correct again. They sell me a harness. They're like, look, if you're techie and you want to do all this, or you tell us the make and model, and we'll sell you a harness for $45, but you snap it into the back of this thing, and it clicks exactly into your Civic or whatever it is. And in 8 minutes, this super intimidating thing to connect to the parking brake and the backup camera and all the other stuff, it just worked. And they get their tech on the phone. I'm like, I'm not sure I'm following it. Hold on. Send me some pictures. Nope, you don't have to hang up. Just send me the pictures. We'll do it. Click, 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 click. I look, my kids are like, you're a genius. Nope, got a harness. That, I think, is the advantage of I'm retrofitting this vehicle and these other things. Anyway, I don't know if that's an exact application, but that's what it reminds me of.
Well, and the thing is, the change management idea is where I think, probably one of the things that we do poorly in our industry is how often after a project is done do you go back and review the lessons learned?
Yeah. Well,
I mean, if you go to any other industry,
yeah,
right, especially when it's a government, sponsored project, at the end you go through the lessons learned, and then if things had a material impact, right, change orders or let's say pricing or acceleration. These are things that you as a business want to actually roll into the next one.
For sure.
And we don't really do a good job of that. We don't look and say, hey, from the order to delivery of the switchgear was, one of our longest lead times, or, the CDUs or whatever it might be,
Right.
and say, how can I reduce those timeframes? How can I make that faster? And then you go work with your partners, right? I think that's something that, I would like to see, and I'm encouraged at Oracle, is that we're looking to be very good vendor partner, right? Where we want to establish those relationships in a way where we don't want to do your business, but if we can enable you and give you feedback and, provide a way that it's mutually beneficial. I mean, look at Meta and, whatever people think of them, what they did with Open Compute was brilliant because they essentially said, here's what we want to use to build our data centers, and we're going to let you do all the R&D and all of the uplift to give us exactly what we want. And look at the ecosystem that flourished as a result.
It's incredible.
And yet people say, no, we have to keep this IP to ourselves. We have to keep it close to the chest. And it's like you can look at what they did, and it's obvious the advantage that they gained by doing that. And it's that openness, which is, ironic at some points, has enabled their business. And so, for me, let those people tell you, hey, this is what I do for a living, right? A tech company shouldn't tell a construction management firm how to run their business. Right? We shouldn't tell electrical subs or mechanical subs, right? We should be asking them, hey, how am I getting in your way? How can we do this differently to let you build it faster for me?
Yeah.
How often do those conversations occur? It's typically top down.
It typically is top down, and again, I don't want to turn this into an infomercial for our organization, but for sure as an industry, the advantage and the disadvantage is the disadvantage is there's a lot of people like me with gray hair that have been around it for 25 or 30 years, one way or the other. And we got it figured out, Luke. We got it figured out. We know how to do it, in this man's Navy or whatever. I heard I don't want to quote it exactly, but I heard a really interesting conversation about a female combat pilot that was just talking about the ergonomics of her aircraft and how their feedback, not just to make it more comfortable, like these fighter pilots are courageous and they're smart and they're amazing. And they began giving feedback on the configuration of the cockpit or whatever. And it's led to some really, allegedly, I haven't been in one, but these really cool design changes that because they just had a different perspective, but the cadre were willing to listen.
Well, that's the key.
And they said, okay, well, why could we do that? And all of a sudden, even though bigger frame, the guys were like, holy smokes, my elbows would rest. Like it's just, but it took just that simple, one, you had to be able to listen. Two, you had somebody who said why, instead of just cramping up and trying to do this the whole time, because it wasn't built for a 5'4" frame. It was built for a different kind of frame or whatever. It was such an interesting thing. So in some ways, the disadvantage is we got silver hair, and we got the silver hair tsunami, they keep calling it. But the advantage is, I see it in our staff. Literally, I was telling you this before we went on camera. Half of the people in one of our every couple months, we bring in a class from around the world of new talent, 48 to 52%. So basically, in the middle, world-class electricians, but they don't know how the data center makes money. They don't know the data center business, and the advantage of that is. And to your point about recruiting, we recruit for a certain, I don't know if humility is the right way. We're not looking for arrogance, but we are looking for confidence. Like, I know how not to get hurt. I know how to do these things. I want to ask questions in a respectful way. Our CEO is literally standing up there. We have co-CEOs. Sounds a little weird, but we do. And so Dave Roby, who was formerly our COO, is constantly encouraging this. It comes from the chip fab business. I don't want you to be arrogant. But look, we don't know that we've got it all figured out. Ask us why. And if we're not able to defend our idea, there might be a better way to do things, because we don't want to strand power. We don't want to, or space, or get people hurt, or slow things down. You got a different perspective. Help us to understand it. And I love that spirit. We don't always pull it off perfectly, but I'm hoping we'll keep going down this path. And we've been talking for a while, and I want to get to two other things, but they're related. Power, if we can,
Sure.
Before I feed you, because I know we're both hungry. But one is you've got this relationship with Stargate. I want to get to that wherever you want to talk about it. But where's microgrids fit into all of this? Because that seems to be what the whole world's talking about. Bring your own power. I was just speaking in Utah the other day, and the governor announced, bring your own power. And, wherever you want to go with that, is there a real role? Do you really think there's a role for on-site power generation? How do you think that's going to work in light of this conversation we've just had? And what's going on with Stargate that you can talk about?
So, yeah, I am the large-scale power lead. I'm the tech lead for, large-scale infrastructure for Stargate.
That sounds so cool.
For Oracle. It's very nice to be able to say that.
Yeah.
But I'm a recent hire too. So, Oracle is transitioning from the co-location only kind of to, we have an advantage in that we didn't do it about the same time as the other hyperscalers. We built our colo business. We've got a very strong, book of business, and we have allowed others to kind of chart the path before us.
Sure.
And if we're smart, we will take the lessons learned from them and do it slightly different. When it comes to Stargate, the thing that is amazing about that project, in Abilene in particular, and Stargate, this is one of those things. Stargate refers to the larger thing.
Right.
We just happen to be the first build down in Abilene. That particular build, what's amazing is how quickly and how much it's going up. We are going to be at 1.2 gigawatts, which is all public knowledge, within 18 months.
It's incredible. You say gigawatts. We don't even giggle when we say that.
I mean, that's Back to the Future. It's 1.21 gigawatts, right? So Doc Brown, in the time period that the sequel wasn't made, right, we're going to have deployed that much. Wow. And so we don't really do things necessarily complex in our industry. It's just the scale at which we do it, right? You go to other industries, you're going to see much more, an aluminum smelting plant has a much more complex electrical system than a data center does most of the time. So if you look at where we're going, it's the ability to deploy that as fast as possible, right? And so the other thing too is we couldn't get power. So we have some bridging power. We have 300 megawatts of gas turbines on the site, which will operate as bridging power. And then eventually they may move to a backup mode. Maybe they'll be peaking. We don't really know yet. We're going to see how the GB200s behave on these. And so there's a lot of challenges of being the first mover.
GB200s are
for NVIDIA's
GPUs,
new GPUs that have been released recently, and they're the current hotness that are actually in the field. So it's a question of how do you do this as fast as possible while providing, and you can go look at the permits, and we're doing things slightly differently, where, AI doesn't need to be your traditional compute, right? And so, the customer is very willing to, look at things to do it differently. Maybe not deploying backup diesels, right? And you can buy more GPUs by doing that. And so there's engineering design choices that are being made, and it's nice to be at the bleeding edge. And when you mentioned microgrids, I think the term microgrid is a bit misleading. When people think of microgrids, most people think of small things, right? We're talking about, 1 gig or 2 gig size microgrids.
Right.
Those are more macro than most people realize. Yeah. And what I think you're going to see is we're going to move away from, central utilities having their own distributed nodes to where private operators might be contributing to the grid in a meaningful way, where SMRs, if you look at the designs for availability that you would need to do that, no data center would consume all that power.
Right.
So even as you design these, thinking about how you can benefit the community, right? If you're running turbines, you're going to generate a lot of heat. Is there an industry that could utilize that heat in an effective way, right? Co-locate with a brewery or something that can utilize that heat in a truly effective way. If we were in Europe, district heating, stuff along those lines. So
Or
there's
Buffalo.
or unfortunately there's no steam. It's mostly oil heat in the basements. But it's the idea of how do you integrate into the larger, we were previously, our industry were consumers, right? We took. And we paid handsomely to do that, right? And we contributed in that way. But I think you're going to see more contribution to the larger system where large wind or solar projects that are private wire or battery energy storage that are co-located near data centers. I think you're going to see a lot more master planning around. You see the RFP released by the government with the 16 sites for AI dominance here in the U.S. Same thing, they reopened the RFP for the small modular reactors. And so you see a lot more viewing this as almost master planned data center communities. Right. You'd see that, schools and shopping and all that stuff were built into some of these things. I think you're going to see our data center industry start considering, hey, how do we ensure that we can get talent to live close by? How do we ensure, hopefully we don't get, the robber barons, mining towns, stuff like that. But, approaching it from being a part of the community and contributing in a meaningful way, right? If you water, reclamation plants or, hey, maybe I generate hydrogen, if I have excess electricity from my private wire type stuff. There's a lot of things that I think as we move forward, we're going to move away from just your typical power plants that go on the grid that are owned by the utilities. I think you're going to see a lot more participation by operators in the very, very near future.
Well, it's a conversation everybody's having. For sure, I think we're hoping as an industry, or we're working towards, at least some of us, we want the data center to be thought of as like the fire department. Like it's an important, you want your data to whatever degree you can local, whether it's, we talk about data sovereignty at the nation state level. More and more we're hearing conversation about not just latency of apps, but I need it to live in my county or I need it to live in my state for whatever reason. GDPR, thank you very much. Yeah, exactly. And so how do you do it in a way, so if you bring the capacity of a facility like a data center, and then also kind of where we started with our conversation with why, whether it's Buffalo or Minneapolis or whatever, I know you're doing it with oil now, but is there an opportunity for new development to do this with heat? No, it's too expensive, or we don't have the right. Okay, but how can we're generating, whether it's heat, we have this capacity, we have these other things. How can we do it? We've seen designs that are going into areas where, well, you know what? I'm not even going to get into that detail here because I don't want to get in trouble. But I guess what I'm trying to say is, already we're seeing, at least in our world, iterations of a design that not only don't use local water or their aquifer, but in the way that we're deploying them, we help fund and subsidize so much, not just the tech labs in the school, which is spectacularly important, but these other infrastructure components. We don't want to be a taker. We want to be a participant. And I don't mean this to, this is a public service announcement, but I really think that if we're going to be successful, either as individual companies or as a nation, that we need to go do that. And when we're talking about on-site power, maybe a better way to say it than microgrid, the questions though still for me to be answered on who owns it. Does it? Do I as an operator own it? Does my customer own it? If we get to SMRs, they need maintenance from time to time. So I for sure need to have some sort of, whether I have multiple deployments in various ages or states of, fuel capacity, like back to your original comments about systems of systems. How am I thinking about these systems so they're holistic and whatever the availability and safety I'm trying to think of, who owns it? What's the regulation around it? How do we do it so we can stick to our core competencies and deliver ultimately for our constituents whatever the result is that we're trying to give to them?
But it's the same evolution that you saw in our society too. If you think about, up until let's say the 80s and 90s, where air travel became, more readily available, right? The globalization of our society has essentially shifted from central constructs, right? You always had to go to now you have choices. It's the same concept, right? Where you now have the ability to build your own city, power grid, or in the same construct that existed at a large macro scale will exist at that smaller scale that then just interacts with the larger entity. And so the challenge will come, how do you ensure the availability and reliability of a grid when that grid operator now has other people wanting to play in their game? And so that interface, that, hey, what dynamic study do you need to do? What model do you need to provide to me? What are the things that if I want to connect to the grid, either distribution or transmission, or the operators need to be able to have that conversation, because it's not that this isn't going to happen. So you can either be the person that says, no, we're not going to,
Right.
or you can embrace it and say, all right, we're going to control the outcome. We're going to, if you want to be the first mover, because you get to define what everyone else follows.
Right.
Now, everyone's going to complain and say you did a terrible job, but you want to know what? 1.0 is mine.
Right.
And now you have to come talk to me because it's the de facto.
Right. Yeah. I mean, it's an exciting time. Right?
It is.
It's if you like change, not just for change's sake, but change, which means many times opportunity, especially if you approach it with this, not just curiosity. I want to be world-class at what I do. I want to be safe. I want to deliver a product that solves the problem, even if it's version 1, hopefully version 4, and the iterations long, get safer, get more efficient, get more cost-effective, all of those things. But to have version 0 of Fire and version 1 of Fire is a world of difference. To have no energy and now have energy with its challenges. Nobody in version 1 wants to go back to version 0. Like, let's keep iterating.
Sure there are.
Well, fair enough. But I think the opportunity to harness these things, but if you approach it with this operational maturity we talked about before and curiosity, it's what an opportunity ahead of us. So speaking of ahead of us, what do you think the things from your seat, your last 20 years from the Navy to now, were the things that are really interesting to you?
I think the digitalization of infrastructure I think that's the next 20 years. I think for interoperability, if you look at our world was not very interoperable until digital became a thing, right? It's making a protocol buffer essentially on the industrial side where I don't have to worry about, the goes outs because someone else is dealing with it, right? I think you're going to see protocols that enable that interoperability. I think you're going to see the adoption of automation in our industry, because the way that we're trying to do things, telling somebody to go faster rarely works, just like telling people that they're wrong. Right? They don't change their mind because you told them they're wrong. They don't go faster because you said go faster. Right. To an extent, they do. And we've reached a saturation point where offering people money, they can't go faster.
Right.
Because somebody else has already offered them that money.
Right.
Or there's no physical way for them to do it. So I think you're going to see the point at which now innovation needs to happen to enable the current trajectory, right? You're seeing them looking at SMRs, right? We're about to have a nuclear renaissance. I think you're going to see some of the more first principle things start to be evaluated as well. And I think you're going to find switchgear vendors or mechanical manufacturers or generator vendors that figure this part out are going to be the ones that benefit the most.
Yeah.
Because then it's easy to buy from them when you solve those active problems.
I completely agree, and I just thinking about when you digitize the way that you're talking about, the hooks into my supply chain systems, the hooks into my planning to be able to, not necessarily just in time, but to shift and move depending upon where the opportunity is, because I'm not trying to solder a whole bunch of people. Like in all those ways, if I'm getting switchgear, that I can in a much more dynamic, quicker, maybe even automated way, redirect it because I got a standard design that's highly flexible, but I'm integrated into their back-end infrastructure in a way that I was talking to one of the largest manufacturers in the world of electric and mechanical components. I was like, why can't we just do this? And they tried to explain to me the challenges of the supply chain from across the world to now. And I didn't disagree with them. I didn't have a concept of it, but I remember saying to them, but man, if you can, whether it's here, it's reshored, or whatever it is, but to the degree that you can let us get more connected to that, and it's more automated. I don't know if it feels like you're giving up control or whatever, but in the, how could we do that if that were more the thing? And I'm not trying to be disrespectful or try to say it's easy, because it obviously, as he described, all of the things necessary, but I just hear a lot of vulnerability.
Well, it's the same thing, when talking with kids. It's, don't tell me why you can't.
Right.
Tell me why you can.
Yeah.
Right. Everyone knows the problems.
Yeah.
Right. Everyone sees the problems. Okay. Let's do something about it.
Yeah.
Right. That's the challenge. That's what excites me every day. I don't think about the way that we do things today.
Right.
I think about the way that we need to do it 3 years from now, 5 years from now.
Yeah.
And that informs every decision and every thought that you make. And you always tie it back to the business decisions. How do I accelerate revenue, right? And we as Oracle are slightly different in that a lot of our customers are third party, right? We don't have internal services that if we delay a build, right, well, it's okay, we'll shift ads around a little bit, right? For our customers, those dates we have to deliver on. And so for us, we almost have a little bit more of an incentive to try to do things differently and take on a little bit more risk, because the benefit for us is a much higher upside. And so I think what you're going to see, and people ask about AI. Most of the stuff in data centers is machine learning. On the and most people don't understand the difference between AI and ML.
Right.
But I think where you're going to see some of the advancements come. I'm a huge fan of being able to feed a PDF into AI and just start asking it questions, extract data from it, right? If you want, I'll give you an example. How often do you go look at commissioning test reports?
Me, never.
Okay. What if I took all of those commissioning test reports and fed it into an AI model that I had trained to look for abnormal results, and then it just flags them? Right? Or that data, even better, it doesn't come in a PDF. I get it in an XML or some other ingestible form that I can now take proactive action. I think you're going to see the digitization of the administration of what we do affect things in a very positive way as well.
Yeah, I agree. John Trout's been on here a couple times. He owns Check Hub, and he talks about that. He talks about you have your tools walking. When you walk your rounds, you do these other things. How it can leverage training, and so you get your senior, your master chiefs that are the experts. But as you're walking, they gave an example of how it suggested, why don't you change your rounds up like this? Or as you go do your things. For example, you were talking about earlier about have no lights on, only exceptions. The way I noticed an exception on I guess Samsung's figured this out, my refrigerator the other day, it only has a blue light like okay, unless it's not okay. And now it's flashing a red light, change your filter, we got an issue or whatever. I would never have noticed it if all the lights had been on about the freezer temp and the fridge temp and all this stuff it could report on that lights up when I push the panel, but it just pointed out the exception.
My favorite is the thing that says whatever normal, and there's a light for it. And if the light goes away, it's not normal. And so it's like, okay, that's the least obvious way for me to get noticed. So.
Luke, we've talked about a lot. What should we have talked about that we haven't? We're not going to start another podcast for another 2 hours.
We are not. Honestly, it's been a lot of fun. I think this is one of those things that we kind of touched at a much more strategic level, probably because of our audience here. I think we have the next 5 to 10 years is going to be a lot of fun.
Yeah.
I think we're ripe for innovation. I think we're hitting a saturation point in a lot of things that, in the past have been hard to do. And I think on-site generation, I think the acceleration of builds, it's going to get a lot of fun.
Yeah.
And, you talked about some of the things that we should have talked about. I think encouraging the trades, mentorship having some of our larger companies invest in some of the local unions, to get more apprentices, to get some folks that maybe need to transition from other, occupations. We have a dire need of people that can build and operate data centers.
Yeah.
And, we complain about the absence of, capacity. Let's do something about it. We're doing on-site generation to make power. Let's do something to make people.
Yeah.
I mean, and I don't mean that in the,
No, I know what you
we
mean.
have to wait 20 year kind
Right.
of.
That's right. Look, two ideas have come to mind, and we'll wrap this up. One was, I don't know if it was somebody from the trades. I want to say it was, but it's been a while ago. We've got a 1 million square foot, 80 megawatt facility down in Atlanta, and we've now added 3 more facilities about the same capacity on that same property. We cannot quadruple our staff. It's grown significantly, but we can't. There's no ability to do that. One, it's not that workforce available. And somebody said, well, what if nobody likes to be on a roof in July or August in Atlanta. What if we flew drones, like you just tell them they're programmed with IR cameras, and have them fly a racetrack over the roof looking for thermal anomalies, and when they find them, they send a tech. Instead of having techs walking around millions of square feet of roof. We're like, let's learn more about that. Like, how interesting. We have more techs than when we started, but to apply technology to supplement, because I want the subject matter experts checking it out and looking at the anomalies and the surrounding area. And another one was, one of my nieces the other day was telling me, it's just a brilliant idea. She's in the food industry at a university in Virginia. And she said, my skill set really is supply chain and project management. And I've got perishable stuff. And it's okay, but I really don't want to remain in this industry. And I'm looking over, she was suggesting oil and gas. I said, don't look at oil and gas. You should look at data center infrastructure, because we need supply chain critical thinkers and project management critical thinkers. She loves the idea, and now she's investigating it. And I just want to encourage people to come and evaluate, nothing against the food industry, but come and evaluate the industries that are trying to innovate, that are trying to think outside the box, that are growing because of the importance of data, whether it's being used by artificial intelligence or any of the other components, the digitalization of our world, our healthcare, education. Come and join. Come and taste. You'll see that it's good.
Well, and the irony is we need the people that were in other industries that know how to do it differently, because this is an echo chamber. And, if you don't have outside talent or outside, viewpoints, we will continue to do the wrong thing over and over again.
Or at least the same thing.
The same thing.
Yeah.
Well, if you do it, over and over again.
Yeah.
Right. The only thing in our world that's constant is change.
Right. That's right.
And so if you try to perfect something, it's a losing battle. Just embrace the fact that everything is going to continue to be different and control what you can.
Yeah. Well, that's a great way to end it, Luke. Thanks for coming on the show today.
It was a lot of fun. Thank you very much for having me.
It's my great pleasure. Hey, if you liked that, hit the like button. And if you loved it, hit the subscribe button. We'll see you next time, everybody. Have a good one.